thank you to joining this talk or for joining this talk. I will talk a bit about release happiness. Originally, when I came up with that talk, it was what I noticed when I was at clients that they often want to have some guidance when it comes to releasing and how do. Everybody thought it's such complex to do a release with all that stuff which is related to releasing, and some of you guys might have used the Maven before and used the Maven plugin. Who of you knows the Maven plugin? Maven release plugin? Yeah, and people asking, demanding for some similar guidance for that. We never implemented a release plugin as part of the core Gradle distribution because I think one fundamental difference to the Maven world is that we don't consider to know how you should do your release in terms of what your processes are. I guess you have way different processes than we have and custom stuff. So that's why I just want to show you this year how you can use plugins in the plugin portal which help you to model your custom release process here. So, short intro about me. My name is René Grischke. I'm working for Gradle Inc. now for 3 years. Living in Berlin, old continent. No pets. So, just quick. So the motivation again. What's the motivation about modeling your release in your build? Well, obviously it's the first one, which is I think the main reason why you want to do it. You want to have reproducible releases. Usually, who of you has experience with what I call manual releases in terms of doing it from the dev machine? I thought everybody did that once in a while, or just too ashamed to raise your hands? Or? Okay, I did that a couple of times, a couple of years ago. So, what you want to have is predictability, right, and stress-less releasing. So, if you automate that kind of stuff, that part of your process in your software engineering process, you can. What's the side effect of that is that you can have way shorter release cycles because if things are automated, it's way less stressful to do a release. If you, I don't know if you joined my talk before where I talked about how we do things in Gradle. So, like when we deliver a feature, basically we implement a feature, we consider that feature as complete once we have added the documentation and we did the release notes. And what this enables us to do is that we say, okay, now we have enough features in it, we just can do a release whenever we are happy with the state of our current master branch or whatever. We can just run the release and we have no extra steps doing it, or we don't postpone anything to the release day in terms of, oh shit, I need to clean up the documentation or I have to write the release notes and stuff like this. It's a continuous process, quite similar to, or it quite matches what Jens talked about doing continuously improvements. And that's an enabler to do way shorter release cycles. You can decide when you want to release and not the other way around, that the software decides when you do release. And last but not least, you have way more relaxed release days. I don't know how your release days went or when you do release. I used to look like this somehow but I should really more. It should be like this, right? It should be quite less because you release it and then you push it and then you just wait for all the goodness coming in and praising you for all the work you did. So when I talk about doing a release, what does that mean, or what do I mean in this context of that talk? What I mean by this is dealing with the typical things you do when you do a release, like dealing with the project version, updating it automatically somehow, or we will do that later. Dealing with your dependencies is also something you might want to deal during the release process. It depends a bit on how you deal with releases or with dependencies at all. But we, in general, say, don't use snapshot versions, don't use dynamic versions, bring it back to just have reproducible builds that you can rebuild after a year, checking it out again. And with dynamic dependencies and stuff like this, you don't have that, right? If you have a dynamic version in your release, which is, let's say you have a dependency on log4j, let's say, and it's version 1.plus whatever, you're definitely not able to reproduce that build in a year or so, because you will never get the same log4j version. You will get a newer one if a newer one was released, but that's nothing you can know upfront, stuff like this. Then you usually also deal with your VCS. You might want to do some tagging, branching, whatever. It depends, again, on the workflow of your company or your project. And then, of course, you want to publish or deploy it. It depends a bit on the type of your software. I guess if you're doing some web service stuff, you want to publish it. If it's just a simple jar, you want to publish it to Artifactory or something like this, or your own Nexus, whatever. And there are other parts in your process or things in your process or in your software engineering environment, like the issue tracker you need to interact with, mark things as done and mark as versions as released. So we, for example, we use Jira, and Jira has that feature that you can say, okay, mark that version as released and stuff like this. And that you might want to do as part of your release and automatically do that. And let's see if we find time. You want to roll back if something failed, or you want to have a safety net if something goes wrong during your release. Might talk about that. So first thing I want to talk about is versioning. Gradle offers you a vast way of dealing with your project version. So the straightforward thing is doing it like that, assuming that the build.gradle file, so you write your version just in your build.gradle file. It works, but it's really hard to, or it's easy to maintain manually. You just enter the build.gradle file and you update that version once you have released or something like this. And it's easy for you to pick that up, but if you want to automate that stuff, it's quite hard to. You would need to look into your build.gradle file, parse a line where the version property is set, and then add some logic to increment that. Way better or way easier to deal with the version is writing it, for example, in a properties file. So if you wrote it directly in the gradle.property file, it's way easier to automatically deal with that version in terms of updating it. You can, as part of your release, you can just read that property file and you can all use that Java sugar with that properties class, or even Groovy sugar on top, and incrementing it as part of your logic or your build logic. Or if that's one approach, I put it here because we use that. We basically put the release version in a separate file. One benefit of that is that you have one dedicated place in your VCS or in your source control system where you can just track which version was released at one date. So if I do a history on that version txt file, I basically get the release, all the releases listed we did for Gradle, for example. Let me use one slide for talking, or let me talk a bit about semantic versioning. So semantic versioning is a way of adding some meaning to your release version. Usually, I guess if all of you are engineers, you usually, I had plenty of discussions with the marketing guys. Oh no, let's name that 2.0 or let's name that 3.0 or whatever. They wanted to tell me what version I have to set. And if you have to deal with that kind of crap, where marketing comes into releasing and talking with you about what the version number should be, you should.
I laugh only because I've had to go through it myself.
Pardon?
I laugh
No, because what I tend to say is, well, introduce a marketing version. That's it. And you as a release team or as an engineering group, whatever, use some other stuff. Separate that concerns, because if they really, because they don't, for example, if you use semantic versioning, you have a meaning in terms of, okay, major means, if you increment or have a major release, it basically means incompatible API changes or stuff like this. And minor means functionality is backwards compatibility added, and bug fix means, okay, we fixed some bugs, but basically we added no feature. But when you have to deal with these guys, they might say, oh, it's April, it's a good day to do a major release. And there's no technical reason for doing that, just marketing. And that's fine, that's their job, but they can do whatever they want, but they shouldn't participate in my release process and how I want to drive that. So there's even a specification about that semantic versioning stuff located at samware.org. It's quite interesting to read. It adds some more stuff to that major minor bug fix thing, like you can have extensions, stuff like this. It's an interesting read if you don't do that or don't doing that at the moment. And there's even a plugin for that in the plugin portal, which is really referencing that samware.org website, and it's called VCS Semantic Version. So look it up at the plugin portal. But it's really easy to introduce semantic versioning with Gradle. Basically, what you can do here. So on that slide here, I just assigned a string to your version, or some of you might have used digits to represent the version. But what some people might not know is that you can assign any arbitrary object to your version property in Gradle. So you can have a custom class like my version. I should have named it semantic version or something like that. Sorry, and you could model the version in a richer way, and you can deal with that later on. So here I created that minor version class with major, minor, bug fix fields, and all I need to do is when it comes to what Gradle does later on, when it attaches, for example, the version on a jar file or on your distribution, whatever, it calls it toString method. So you just need to have a string representation of your custom implementation of your version, but it adds you way more flexibility. And then you might want to read that from a version property file, and so you have the combination of both semantic versioning with a rich model and having a dedicated place in your source control to deal with it. One thing I wanted to add, apart from doing that major minor bug fix, is that a lot of companies add more information to their build. So is anybody adding their revision or their Git hash to their release stuff? Yeah, a lot of people tend to do that, and the nice thing about that is that basically you add complete traceability, right? You look that up at the customer or whatever, and you can see directly which version it is, and you can have a shortcut with your engineering team and say, well, that's a hash, check it out, test it. That's easy. Here in that example, what I wanted to show here, like what Eclipse does, for example, they have a version, so they have that version here, but they also track the build ID, and so does IntelliJ. So all these engineering tools are already doing that, so that they have full traceability, and that's a nice thing to have. I'm not sure. You just need a place where you can look that up. So what I did in my former company is you have that marketing version 2.0 whatever, and you have these additional information on somewhere hidden in the version info page. That's helpful for the developers to add that traceability. And you can do that quite easy in Gradle. So that's just a sample. So what I have here is I added a properties file with just 3 items in it. There's a version property, there's a revision property, and the build number. And so assuming that's a Java plugin, I know some of you are doing native stuff, so but easily applicable. So if you have a Java plugin applied, you have that process resources task. I guess you know that. What you can easily do is using that filter operation that Gradle offers. So you can use that replace tokens aren't filter, and just pass in the values for all of these fields. Like the version number, it's pretty straightforward. You just take the project version property and pass that to your info.properties file. For the build number, I checked it. I think TeamCity and Jenkins, they both have provided system properties or environment properties which reference the build number. So if you want to have that, like the Eclipse guys or the JetBrains guys do, you can use that way of doing it. And revision, well, that's of course, it depends on what you use as your source control system. But in Git, there's a really easy way of doing that. You just can do a really simple file operation there, because in .git refs heads master, assuming you're releasing for master, that's where your revision, or that's where your checksum is located. It depends a bit how your TeamCity works or how your CI box works. Some of them don't have that .git repository, but you get the idea, right? And there are plugins out there for dealing with version control system like SVN and Git, and also some others, yeah. Which just rely on plain Java. So there are Java implementations for Git like JGit, and there's SVN. What is the famous? I forgot the name, but there are libraries for dealing that. So you don't have to rely on your installation where you run the release. You can really do that by just adding libraries to your Gradle class path, or adding plugins to your Gradle script. One thing to keep in mind, or one thing that you need to be aware of, is that if you add those versions as part of your inputs to your build, you want to also mark them as inputs for Gradle. So I guess all of you know that incremental Gradle feature, that the task is considered up to date if the inputs don't change and the output is still untouched and there. Good. So basically what I'm doing here is I say, I augment that process resources task and say, okay, I have additional inputs for you. I have the version number, the revision, and the build number. And as soon as something like this changed, like the build number changed, this task will be considered out of date and run again, so that you are really sure that the build number is updated, for example. By the way, if you have questions, just yeah.
Are you reading from the properties file here?
No. Well, that doesn't matter. You mean where you read that version property from?
Yeah, is it something that Gradle will do for us, or is it just somewhere?
Well, I just reference that project version object, which can be anything. It can be a string, but I can also have added that logic somewhere earlier. What will happen?
It's not magic that Gradle will read it.
No. No, it's quite, no, there's no magic around that. The project version must have been set somewhere in your build before. Otherwise, the default is I forgot that. It's unset or not set or undefined or something. But you have to, that's something you have to do anyhow, set your version. How you do it doesn't matter.
There we go. I was just going to say, some people like to include a timestamp into this thing, but you have to be careful. If you treat that as an input property, it will run every time, and you issue Gradle every time it's changed.
Yes,
That's
so
something you want, but a lot of times that's sort of an inconsequential property.
yes. The question is, if you have timestamps, if just the timestamp changed, there's no reason to rebuild it. So you don't need to add that as an input property, because then, okay, you take the old jar, and it is the old timestamp because that's it. The only, one thing you might want to consider if you have a huge build with a lot of multi-projects, you might end up with having a jar file which has a different, or you have different timestamps for different modules. But okay, usually when you do a release, let's say you're doing it on the clean field and you run. Some of you guys run clean up front, but so that shouldn't be an issue. So last year I did this quite a similar talk, but I hacked everything on my own here to show how easy it is to do that in Gradle. But last year we also added or announced the plugin portal. So what I really wanted to do is to double check if there's a plugin in there which is helpful to doing that or does that stuff for me. So I bet that's the output I get when looking for the term release in the plugin portal. I got plenty of plugins. So there's this, I guess this is quite a famous one from the Netflix guys. They have one that works quite well, is really well documented. There are other ones, there's a Swiss one, so there's one from the Valley, one from the Swiss, one from Poland. You can see there are different versions out of that, and here you can see that and everybody sees the way how you want to release might be maybe a bit different. So what I will use in my demo is actually that one. It's a net ResearchGate release. I could have used the Nebula one I tested. They're quite similar, but yeah, these guys are from Berlin too, so I have to be some local support here. So yeah, let's take a closer look on that release plugin. So what I have here is I just wrote a really simple Bootstrap Spring Boot app, which does more or less nothing. I can show you. I'm not a web guy, so don't expect much just for demoing. So what I have here is simple Spring Boot app. Just, yeah, greetings from the Gradle Summit, and giving some weather information. And the interesting part here is that I added some logic to read out that property file just to make the release number available on the UI. So here you see at the moment it's a 1.5.3 snapshot version. Yeah, here I added some more logic. And here we have defined the version in the Gradle.property file. Now let's take a look at that build. It's nothing fancy. It uses just the Spring Boot plugin. But what I want to do is I want to use that release plugin and see what I get out of that. So here I added that ResearchGate.release plugin. And what that gives me when I run Gradle tasks, it provides me some release-related tasks. So there's an after release build, before release builds, plenty of them. You can read the documentation, what all that means. But there's one which sounds interesting. It's just named release. So let's go ahead with this one. It seems to take care of everything. So if I run release now, the first thing it does, it asks me for a new version I want to have. So let's wait a sec. So and if I move on, I say okay, accept that 1.5.3 version. It complains about. So what you have here is again. It complains about the snapshot dependency. So that's the second item on my release overview, what I want with the release. You don't want to rely on snapshot versions in your releases. So let's fix that. what I basically, I just commented out. I just added the snapshot dependency to demo that stuff, but actually I have no dependency on it. So I just can remove that dependency here. And what I get out of that, test it again, okay, it's working. And if I run the release task again, now it starts complaining with some other methods. It tells me that the build.gradle file is touched. So I have uncommitted files. So I don't want to have uncommitted files when I do release because it's not reproducible. If I do the release and I crash my box or whatever, it does not work. So I need to commit that stuff. So that one really need a lot of time. So push that, and now we should be able to do the release. Yeah. Here again, it asks me for the new version. I say, okay, 1.5.3, just entering enter. And basically, we did the release. So if I take a look at that log, it does the tagging for me. If I go to github.com, I see that the version has been, or the new update has been pushed, so it's safe, it's shared. The only thing that drives me mad at the moment is that there's one manual step inside it, because it asks me for the version that nothing I want to do usually. Usually I want to release on the build server, right? So it should be automated. So let's take a look at how we can do that. So what I have here is I added that semantic version thingy with that major minor bug fix and even an extension. And what the plugin looks for, if we go to the documentation, it has a README with a lot of content in it. So you have to add some properties, like you have to set that use automatic version, and you have to set the property named next release version. And if you go here, what I do here, I use that semantic version class, and what I added to that class here is that I said, okay, this class knows how to calculate the next or the new version I want to release, or that one does know what the release version I want to use. And I can put all that logic into that class, which does know all the version-related stuff. And I can even add tests for that if I want to. Usually I put that in a plugin, right, and wrote tests for that. So once I did that again, I pushed the Gradle file, the change one, and now I can run Gradle release. And what I see here is that now it's doing all the stuff automatically. It does not ask me again for version information. I can just run it this way on the CI machine. Yeah, so that's the first thing when it comes to releasing with that plugin, how that works. It was really easy to use that, and it's really well documented. So next topic or next thing to take a look at is how we deal with publishing and deploying. Gradle works quite well with different other software stacks, like for example, there's an Artifactory plugin. You can publish to Artifactory just using the Maven or the Gradle publishing task, which works really well. But there's even a maintained Gradle plugin for doing that Artifactory publish. The nice thing about that one is they have a richer API when it comes. If you use that API, it's richer than just the Maven syntax. And they do something like you can track, like you can store additional properties in your Artifactory. So you can attach to a jar you publish, you can attach the build and link the Jenkins job or the TeamCity job, whatever, back, and you have that full traceability. But I don't want to sell your Artifactory, so you have to figure that out on your own. Yeah, and there are different, of course, since Gradle is way flexible, there are plugins out there for Docker, publishing to dealing with Tomcat. There's a talk running parallel, I don't know, about dealing with web servers. Yeah, all different kinds of stuff. So what I wanted to do for my sample app is just deploy it to Heroku. What Heroku offers is a quite interesting way of doing it. You can have a custom remote repository which points to Heroku, and during your release, when you say, okay, I want to publish, what you basically do is you just push it to Heroku, and Heroku takes the sources, and it has a Gradle functionality that it sees that it's a Gradle build, and it builds Gradle and deploys it automatically. So let's take a look at how that works. So here's the remote branch. It's quite easy to set up. Heroku offers a command line tool which does all the stuff for you, and basically, yeah, it's really easy to use. And even I got it running, so must have been simple. So the only thing I need to add to my build is I need to wire it somehow in the process of these tasks during a release, and I need to do that Git operation somehow. So one way, I told you earlier, what you can do, you can apply a Git plugin which offers support for doing Git on a plain Java level without relying on anything installed. For that example, I keep it simple here. I just run an exec task and I call Git, and all I do is push Heroku and push the master branch to Heroku. Okay, wire that stuff together. Again, I need to take care of that everything is deployed. And then I need to push it because I can't build it up front. And now if I build that stuff, you will see different build here. Now doing the release. And now what's happening here is that's basically the output of the Git command. The output of the Git command when you push it to Heroku. And what it does is it detects it's a Gradle app, and then it runs a build again. It's an interesting approach of pushing sources. That's something that the Spring Boot guys are also doing. And then it tells me, okay, here's a URL where your newly deployed application is running. And if you go there, yeah, no surprise. And now you see that different version here. That's the one I just released. And there are different. There are other plugins for doing that with Cloud Foundry and stuff like this. Yeah, really easy. What I might want to show you, you need to tell when the Gradle build is finished. You need to tell Heroku how does it figure out how to start your app. And basically, it's a proc file. They call it proc file, and you just say, okay, it's a web app. And the way you start it is you just want to say Java opts, which you can configure on the Heroku website. And then you just point it to the jar file and run it. And the Spring Boot plugin took care of making a fat jar out of that. So you have all the stuff in one jar. Easy to maintain and stuff like this. But yeah, something the Spring Boot guys did, not we. So last thing we might want to do, how are we running in time? Is we want to have some smoke tests. So what I want to have is, okay, once I publish that to Heroku, maybe I want to ensure that the deployment went well and nothing, I don't know, maybe during the startup blows up or something like this. So what I did is I wrote some tests based on JEP. JEP is a web testing framework based on Selenium and based on Spock. If you haven't used that, do it. I think I run a bit short, but let's see. So basically, that's a simple test how the smoke test is. I just want to ensure that the page is working. Yeah, nice Spock syntax, easy to maintain. Even I got it working, so quite simple. Yeah, commit that stuff. Then we deploy again. and we run the smoke test, and finished. And if we go to, yeah, correct version is deployed, and the service is successfully deployed. So, yeah. One last thing I want to show. What we do, maybe a side note, what we do at Gradle when we automate things, it's a continuous process, right? When you want to start automating stuff which you haven't automated yet, I think a good approach is always, like doing development, is doing it in an incremental way. Figure out what was the biggest pain point in your last release and maybe automate that and keep some other stuff manual. And once you're happy with the automation you did for that particular stuff, just apply more automation for the next release. And that's how we do it. Every time or every once in a while we figure, well, maybe we can automate even that one, what we haven't figured out before, or we changed tooling and we had to adapt something. And one example of that is dealing with your issue tracker. Like, usually nobody thinks about that. The project lead needs to, when you do release in the evening or in the morning, the evenings before, the project lead runs through the Jira instance and just mark stuff as fixed and double check that stuff. And if he misses something, it does not show up in the release notes or whatever. But in general, all these issue tracker tools, they are really good. They provide a rich API, REST-based, whatever, like Jira, Utrack, Trello, GitHub, whatever you use, I don't know. If you're using, I don't know, Microsoft Excel, then obviously you have more problems than that. But I saw that at clients which use Excel, and of course that does not work. And the other thing is, since they provide REST and Gradle is based on Groovy, and Groovy is so tremendously easy dealing with REST or JSON and all that stuff, it's really something you want to do. Like what we do is we automatically, when we do a release, we query the Jira instance to give us all the fixed issues, and then we integrate that in our release notes, so we don't have to do that manually. One thing I wanted to demo to you is how really how easy that stuff. Shit. Now you figured out that I haven't done that live. So here I have a custom task written, which is issue checker. Basically what it does is it checks if there are open issue in my issue tracker assigned to that version, to a particular version. And if there's an open issue, I can't release. Basically it tells me, okay, you can't release, you have to maintain or update your issue tracker status. And here you can see how easy that is. You just reference, I use GitHub as an example, so the GitHub issue tracker, just because it's free. What I do here, you add you reference that URL of your issue tracker in your sample app, so my sample microservice app. That gives you basically some JSON, and then you use that. There's a JSON slurper. It's a really convenient API for reading. There's an XML slurper too for dealing with semantic files in Groovy. So what you can do is you pass that JSON file, and then you look for an entry where the title is the project version. So that's how the layout looks like. And if the state of the current issue is open, then I can look at if the current release I have the current release what I have at GitHub, if there's some open issue assigned to that, I can throw an exception. So that's what I did. So now I create that task, wired that into that process. So, and now what you get here when I want to release, it tells me, okay, you cannot release 2.0.0 version because there are unresolved issues. You have to take care of that one. So, and you can go back here. There's a URL. You can just click it, and if you click it, yeah, just a dummy one where I said, okay, get the demos done for the Gradle Summit. I demoed the ResearchGate release plugin. I demoed the Heroku integration. I'm almost done with demoing that issue tracker integration, so almost done. I can close that. And now, if I want to do the release again, it succeeded. Yeah. Really easy and fun. Basically it's fun writing that. So we are almost done. 14 o'clock, I guess, is over. One sentence or some sentence about rollbacks. In general, well, if you really automate your stuff, I mentioned that earlier, it's really easy to do releases. And I saw people, especially, I don't know what kind of environment you're doing, but I attended a talk last week where they talked about microservices environment. And what they mentioned is that for them, it's way easier or way more convenient to do forward fixing than doing rollbacks. Once you automated all that stuff, it's way easier to do it that way. And if you, of course, something can go wrong always. You have to keep that in mind. But if you inline if you keep that in mind when doing the release process, like usually people have A/B staging areas where they run on that version and deploy to the other one, the next release, and they cycle around, so they are safe in terms of if something goes wrong, just go back to that other version. That's something you want to keep in mind when you do publishing your stuff to publication. Or usually you have a pipeline, right, where you publish to a staging area, which is, I don't know, internal thing where you test your stuff, or you do, and then you might want to have a final manual step where people or your QA takes a final look at that. That's fine, but you need to model that in the process. With my sample app, just publishing to Heroku, that's easy, but yeah, if you have to support something 24 hours, whatever, that's something you need to keep in mind. There are some links in, I think it's on the tablet, all that stuff. There's a plugin portal, obviously. There's a sample project you can take a look at, clone, take a look at how that Heroku stuff works if you like that. Are there any more questions regarding releasing? Yeah, Jira has a rich REST API you can use to do that stuff.
Is there a plugin for Jira integrated?
I'm not aware of any, but again, it's really, you just need to figure out the endpoint, and it's JSON-based thing, I guess. It's really simple to do that in Groovy. And you could take a look at the Gradle build, I think, because at least there's the logic for how we query the release, what I demoed here. That stuff, that is part of the open source stuff. So it's in the build, or I can show you later. Yeah. Any more questions? Then have a good day. Enjoy the rest of the conference.